The concept for this first problem is variable types. What we're trying to do here is learn the difference between categorical, quantitative variables, and we should also remember identifiers. They're not mentioned throughout this assignment, but an identifier is structurally unique for each and every row. It cannot and will not repeat. So you have to think of something like social security number. So if we have people in a list and we have their social security number, it would not repeat. Maybe their blood type would repeat, or how old they are would repeat, but a social security number is an identifier because it cannot and will not repeat in a lot of data sets and would act like an identifier in those data sets. So let's look at the key difference between a quantitative variable and a categorical variable. Well, a quantitative variable has to be actual real numbers. These are not actual real numbers, so they're obviously categorical because we can just automatically say it has to be categorical. The issue here is, could we use numbers to identify these? And we could. We could call cat group 1, bird group 2, dog group 3, other group 4, and non-response, no response, group 5. If we had done this, it would still be categorical because it's not an actual real number. When we ask people for a pet, would you rather have a cat, bird, or dog? We are not asking them how many pets. We are saying which group do you want to be a part of? The cat people, the bird people, the dog people. So we could call the cat people group 1, and we could code it. It's often called a coded variable. So remember this is a trick we sometimes use, is putting in 1 or 0 or 2 doesn't mean it's quantitative. It has to be an actual real number. I always say look to the question for what we have, and I can't highlight that question for some reason, but look to the question for how you would respond. So would you rather have a cat, bird, or dog? And you would answer, I'd rather have a cat. Thus, your response is categorical. The same concept is going to hold true for the next question we have. A pharmaceutical company conducts an experiment in which they take 50 milligrams of a substance orally. The researchers measure how many minutes it takes. So the question is, how many minutes does it take for the substance to exit the bloodstream? So you have to think about the question, and what would the response be? The response would be something like 5 minutes. So is that 5 an actual quantity? Yes. 5 minutes is a quantity of minutes. How many minutes? And when we say how many, that question right there leads to a quantitative response. So you could have 5.2 minutes, 7 minutes, 8 minutes. It's a quantity of minutes, and thus it is a quantitative variable. Quantity, quantitative. For this next question, we are looking at a pie chart. So let's look at this right here. The pie chart summarizes the genres of 125 first-run movies released one year. And it's pretty evenly split. If you notice, there's action adventure, there's thriller horror, and everything's about 25-25. I know those aren't perfect, and this one might be closer to 28 or 30, and this might be more like 20. It's hard to tell. Pie charts are a little harder to look at than bar charts, and that might come into play here later on. Is this an appropriate display for the genres? In this instance, as the tip says, we are going to assume that they can only fall into one category, and that's, yeah, sure, that is great. This works perfectly. Which genre was the least common? A little hard to see, and this isn't the best display for checking this out, but it's going to be drama, which is yellow. So this is categorical. I want to make that very clear, because what type of movie was it is not quantity, it's category. So this is a categorical question. What type of movie was it? I know it says 125 right there, and this might be 25 of the movies that came out. But what we want here is to look at the question. What type of movie came out? And the answers are categorical. So this was a categorical question, putting them into categories. Going down further, which genre was most common? Now, this one's a little bit more obvious, but it might be a fight between blue and green. But look up here. Ha-ha. And once again, people say to me, but Brian, there's numbers. There's 40 right here. That's a quantity. The question wasn't how many comedies came out. That's not what we asked. We asked, what type of movie was it? And then when someone say, oh, well, this movie was a quantity. This movie was a comedy. This movie was a drama, and there's 20 or so movies that came out that were dramas. You would look at each individual movie and ask, what kind of movie was it? What genre was it in? So, something like 22 Jump Street comes out, and you say, 22 Jump Street. That was a comedy. Something like Gattaca, if you remember, is one of my favorite films from the past, comes out, and you're like, oh, that was a drama. Mission Impossible 5, that was action adventure. And you look at each individual movie and ask, what genre was that movie in? Remember, that is a question we're asking. And the response would be, that movie is a drama. So the response is what we need to look at here to know if something is categorical or quantitative. So this is a categorical question, and we can identify the most common movie for this year was comedy, because it had 40 movies we looked at and said, oh, that movie's a comedy. So 40 responses were comedy. Going on. Is it easier to see in the pie chart or the bar chart? Definitely the bar chart. You're going to have to fight. I think I was going to say you have to fight between the blue and the green here to figure out which is the biggest. But right up here, it's very, very obvious. So the bar chart is obvious in this one. You can trace over a lot easier. On the test, sometimes you might have to grab a piece of paper and hold it up and find out exactly, this might be 35 right here, and this might be 28, and this might be 21. It's a little bit over that 20 if you trace over. So the bar chart is a lot easier to see. This right here without some sort of value labels is hard to see. And so kind of their mistake for not adding the value labels on it, which we'll talk more about when we get to pivot charts and pivot tables. Nice work on that. An article reported on a school district's manager school program of the 2,000, perfect number, because that's a very easy number to use, 2,000 applicants who applied, 1,004 were accepted, 341 were waitlisted, and 655 were turned away for lack of space. Find the relative frequency for each decision made and write a sentence summarizing the results. Well, let's not write those sentences. So here we are. This is, once again, categorical data. Now, I know it blows your mind. You're like, wait a minute. But if I were to ask you, for this applicant who applied, what happened to them? You would have to answer, they were accepted, they were waitlisted, or they were turned away. This is merely a count. I want to make that clear that these numbers here are counts of how many people this happened to or how many qualified applicants it happened to. So once again, look to the question. That is always my tip to people. Look to the question. So you'd have to ask, what happened to the applicant? And then your response would be, they were accepted, waitlisted, or they were turned away. Look to the question to know what the variable type is. So we know we're dealing with categorical data once again, because the question was, what happened to these people? And let's bring up our handy dandy calculator. The question is the relative frequency of accepted qualified students. This is nice, neat numbers. I believe the answer is going to be 50.1%. Let's find out. I might be off. I'm trying to do it in my head as I think through what I'm going to say. 50.2%. I just can't divide 4.5. Can't do it these days. So this wants it as a percentage right here. Relative means relative to 1 or relative to 100%. This is a relative frequency. The difference between a frequency would just be 1004. That is the frequency. Relative, once again, means relative to a percent or 1, as in we could have reported it in decimal format, and then it is relative to 1. Literally means relative to something, because it's not 50.2 applicants. This is relative to all the applicants. It's a percent now, relative to 100% or relative to 1 over here. And we usually like it in percent format and look to see this is the answer we'll type in other questions if it has a percent. This can get confusing sometimes on my Pearson, but the percent is a giveaway. The relative frequency of waitlisted students. So let's see here. We need to divide that in half and turn it into decimal. I think we're looking at, I always like to try to do these in my head, 32.75. Let's figure it out. Take the total, and the waitlisted, I have the wrong amount, and divide by 2,000. That'd be 17.05. There we go. And I'm not doing the math correctly these days. I think I forgot a 0. 17.05. We are merely taking 341 and dividing by 2,000 for 17.05%. I got very lucky that that is a very nice number. And there's an issue here. Make sure to always round the way it wants, or you will get them wrong. Be careful, be careful, be careful. If you're watching this part right here, make sure you've been rounding to 1 decimal, or else you could get it wrong. We're not that crazy on the test, don't worry. Turned away students of the 655 divided by 2,000. Make sure I'm not off the screen here. And this is the 32.75, which will round to 32.8. Be very careful, make sure your decimals are correct. And even better yet, I hate to say this, but you can get the answers for this one nice and easy because on your quiz, you will see all those answers, and the answers are exactly the same as at the bottom. So you should not get that wrong. Okay. The Center for Disease is looking why people die in 1999. Is it reasonable to conclude that heart or respiratory diseases were the cause of approximately 39% of US deaths? So they're only putting death to one cause, and heart or respiratory. So here's heart, and let's do math to double check. I'm going to move this over here. Heart is 31.2, respiratory is 7.79. Or 7.7, and then heart and respiratory is 38.9. And they say approximately, and that's good. And yes, because there is no overlap. You can only have one cause of death, they're saying. That really might not make sense, but they're just looking at here a relative frequency table. Good thing to note here, this is a relative frequency table. Once again, this comes from categorical data. We had to ask, what was the cause of death? And the answer would be one of these right here. So although you see numbers once again, remember the question was, what was the cause of death? Thus, this is categorical data. So let's go ahead and go on. What percent of deaths were causes not listed? So to be a proper relative frequency table, this has to add up to 100%. We've already added up two of these categories. I've added up 31.2 and 7.7. So let's add on 22.6. And let's add on 9.4, if I can. Oh, I've messed it up now. Let's clear the screen. 31.2 plus 22.6 plus 9.4, 7.7, and 4.4. As long as you've done your math correctly, you have the total here, and then take 100 minus that total, and now put this into decimal format, or percentage, 24.7%. And as long as you enter in by the right percentage, you should get it correct. And finally, select the diagram that represents the data. And we only have two choices here. If you notice, one doesn't even have the other. Nice and easy. This has the other, and this is a pie chart. A pie chart represents categorical data. Once again, a giveaway that this is categorical data. Pie charts and bar charts represent categorical data. So does a Pareto chart. Pie charts, bar charts, Pareto charts, frequency tables, relative frequency tables. There are 5 right there that all represent categorical data. Once again, if you have questions, feel free to email me, and good luck.